Hello, Math 151. And here we are with our second lecture. And this one's going to be about matrix solutions to linear systems. So in our last video, we talked about solutions to linear systems, and we used substitution and elimination. And both of those methods have their pros and their cons. And one of the things that's good about elimination is if you can use it, it does allow you to solve some pretty complicated systems. And elimination also leads us to some matrix algebra. And now matrix algebra is actually very powerful, but we're only going to scratch the surface here so you get some familiarity with it in case you might see it in the future. So let's first start off with what we have from last time. So from our last lecture, we had these two equations, and we wanted to solve them. And we talked about using substitution or elimination to do that. And recall with elimination that there was two things that we could do. We could multiply both sides by a number. So we could take an equation and multiply both sides by a number, or divide both sides. And the other thing that we could do with elimination is we could add or subtract equations. So we could take these two equations, we could add them together, or we could subtract them. And these two things, multiplying an equation by a number, and then adding and subtracting equations, we're going to use these two things to build then a strategy of how to solve more complicated equations. So the first thing that we're going to need to do here for our strategy is there does have to be an ordering here. So let me just scroll down here. The first thing we need to do is to make sure that everything is ordered. And what do I mean by this? Well, our equations are going to have three variables now, x, y, and z. We want our equations to be in the order of x, then y, then z, and then equals our number. So this is the first thing we're going to want to do with all our equations given, is write them in this order. Now the book, for the most part, does give the equations in order, but there are a few problems where they test you to see if you understand that the equations do need to be ordered like this. So let's just take an example of that. And that's going to pop up two equations here. So here they are. Now notice they aren't ordered. So we have y, then equals 4, 3x minus z. So the first thing we want to do is we want to order these in this manner here. We want x, y, z, and then our equals. So let's do that. I'm just going to take this equation again here. So here's the first equation. So we want it to be x, y, and then z. So if we subtract y from both sides, we can get the y to the other side there. And if we subtract 4 from both sides, we can get the 4 to the other side there. Now we're almost in our order here. So we want x, y, z. So I'm just going to change the order of z and y here. And then finally, we want this to equal then whatever our number is. We know this equals minus 4. There we go. I took this first equation and then ordered it into x, y, z, and our equals. And we want to do this with the second equation as well. So we'll take this one here. And let's first get the y to the left. So we'll subtract both sides, minus 2y. And let's get the 6 to the right, so we'll add 6 to both sides. And then finally, we want to put this in x, y, z. So we have x minus 2y, and then we'll stick the plus z over here then. And there we go. We now have our two equations ordered. And notice that, we have x's here, and then we have the y's here, then we have the z's here, our equals, and then we have our numbers. And this is the first thing we always want to do for this setup that we're going to be doing. So now the next thing that's going to be completely new is that we want to rewrite this into what's called an augmented matrix. Let me just paste in here a matrix template. And so we're going to want to rewrite our equations now without the variables. And so this is why we want them ordered, because we want it understood that our first column here will be x values, our second column will be y values, our third column will be z, and then we have this straight line bar to mean the equals sign, and then we'll have our numbers. So we're going to take our two equations here, and we're going to simply write them into this matrix, but without the variables. We have a 3, and for y, we have a -1. For z, we have another -1, and this all equals -4. And if we look at the second equation, so we have a coefficient of 1 for the x there, then a coefficient of -2 for y, and a coefficient of 1 for the z, and then finally that equals 6. And this is where we want to get to here. We want to write everything into this augmented matrix. So again, we're given two equations. We then order them into x, y, z, and then equals our number. And then we simply rewrite this as a matrix where we just dropped all the variables then. So let's try another example of that. So here is a set of equations, and let's write this following set of equations in augmented form. So first, notice they are all ordered. They all start with x, then y, then z, then equals, and then the number. We're just going to simply write this then into our matrix. So that means we're just going to write all the coefficients. So if you look at the first equation, if we just look at the coefficients, we have 2, 1, 2, and 2. We'll have a 2, 1, 2, and a 2. We look at the second equation coefficients, we have 3, -5, -1, and 4. So we have 3, -5, -1, and 4. And then finally, if we look at the last one for our coefficients, we got 1, -2, -3, -6. We got 1, -2, -3, and -6. And that is our augmented matrix. So let's try another example. So here's another set of equations. And we want to write this into matrix form. We're just going to look at the coefficients. So the first equation, we have a 1, -2, 3, and a 9. So we'll just insert that to our matrix. 1, -2, 3, and a 9. Now if we look at the second equation, notice there's no x. So that means the coefficient of x is 0. Then the coefficient of y is 1. The coefficient of z is 3. And then all of that equals 5. And then for our last equation, it only says z equals 2. So that means the coefficient of x is 0. The coefficient of y is 0. The coefficient here for z is 1. And then equals 2. And that is our augmented matrix for that set of equations. So once we have our augmented matrix, we're then going to perform operations on this. And the operations I already mentioned, we can multiply an equation by a number or divide an equation by a number, and we can add equations together. So let me just move on to another example here. And it's very common to put the instructions on the right here. So if you look at my matrix here, you see I have these boxes here that I have set up to go. And this is where I'm going to put the instructions in. And your book does this as well. And so let's say we want to take this first row and we simply want to multiply it by 2. And so we would put in our instructions over here that we're going to multiply 2 by the first row. So we would say we're going to multiply 2 times row 1. So again, here's our augmented matrix, and then off to the side is going to be our instructions on what we're going to do here. So this means we're going to replace the first row by this instruction. So we're simply going to replace row 1 with 2 times row 1. So that means we're just going to multiply everything by 2. So this would be 4. 2 times a minus 6 would be a minus 12. 2 times 4 is 8. And then 2 times 10 is 20. And so we carried out that instruction. We multiplied the first row by 2, and then we replaced that as row 1. So again, that means just multiplying a row by a number. Let's take a different instruction set. So here's the matrix again that we just obtained. But let's say this time on row 2, we're going to replace row 2 with row 2 plus row 3. So we're going to replace row 2 with adding 2 and 3 together. So row 2 plus row 3 is going to be a 4, and we're going to replace that back into row 2. And then moving on, we have 5 plus 0, which is still a 5. Then we have minus 5 and a 4 to get a minus 1. And then 0 plus 7 would get us a 7. And so we just completed that instruction then. So the instruction was to replace row 2 with row 2 plus row 3, and that's what we did. So let's check out another instruction set. I'm going to take the same matrix that we have and add a new instruction onto it. So this new instruction says replace row 3 with 2 times row 1 minus row 3. So let's check that out. So it says let's do 2 times row 1 and then subtract row 3. And then we're going to put that into row 3. So 2 times row 1, so here's row 1, so 2 times 4 is 8. And then 8 minus row 3, which is 3, so we have 8 minus 3, which means we replace that with a 5. And let's go on to the next position here. So we have 2 times minus 12, so that's a minus 24, and minus 0. So that means then we replace that with a minus 24. Now 2 times row 1, so that's 2 times 8 is a 16. 16 minus a 4 to get us a 12. And then finally, 2 times 20 is 40. 40 minus 7 to get us a 33. And so then we completed that instruction. And now we have this new matrix. So again, what we're doing is we're doing elimination in a more advanced way with matrices here. But again, we're simply adding or subtracting numbers to an equation, and then we're adding or subtracting equations together. Now, one more thing that we can do with these matrices, and it's not too common to do this, but you can do this, is that we can also switch the position of the rows. So, row 3 could be just switched to row 1. So we can simply switch positions here. So if you look at the instruction set I have, it says row 1 is now going to be row 3. And then row 3 will now be row 1. So we're just going to switch our positions here is all we're going to do. So row 1 now becomes row 3. That'd be a 5 and a minus 24 there, a 12 and a 33. And now we're going to replace row 3 with row 1. So row 1 is 4 minus 12, 8, and 20. And then we completed that instruction. So there we go. We started with this matrix here, and all we did was switch row 3 with row 1. So ultimately, it doesn't matter the order of these rows, so that's an operation we can do is just switch them. So what is all this leading to? So we have these instructions that we're going to do on these matrices. So what is the goal here? And now the goal is to get our matrix in a specific form. Our goal is to get our matrix into this form on the left. Now, this is called the identity matrix, where we have 1s on the diagonal, and then we have 0s in the corners here. This is the matrix equivalent to the number 1, and this is our goal. Our goal is to get the matrix in this form, all 1s on the diagonal and with 0s everywhere else. And then the right side, the 2, 5, and 3, then that will simply give us our answer. So if we take this matrix and rewrite it back into equations, then we can see, looking at the matrix here, this is x is 1, and then 0, 0, 2. So we have x equals 2. For the second row, we have x is 0 and z is 0, and so we have y is 1, so y equals 5. And then the final row tells us z equals 3. And of course, then, this is our solution. And the solution, again, if you recall from last lecture, the solution is where these lines intersect. Now, in this case, we are dealing with 3 variables, which means 3 dimensions. So in this case, these are planes. And our solution here, then, is where the planes intersect. Now, we can work the matrix all the way down to this point, where we have all 1s on the diagonal and 0s everywhere else. We can do that, and you can if you want. But a common strategy here is to kind of only do this halfway. So what I mean by that is it's pretty common to stop doing this matrix work once you have 0s in the bottom left and then 1s on the diagonal. So we can finish the problem at this point with substitution, which is why this is a pretty common area to stop. So if we look at this matrix we have, so again, we have all 1s on the diagonal, and then we have 0s in the bottom left here. Once we have the matrix in that form, we can rewrite it back into equations. So if we look here, we have x plus 5y minus 4z equals 8. But most importantly, our bottom row tells us z equals 3. And so once we have z equals 3, then we can simply plug that into y to get what y is, and then we can plug all that back into the first equation to get x. So this is a common stopping point. Get the matrix in this form, put it back in equations, and then use substitution to finish it off. And that's what we're going to do here, is we're going to work to get the matrix in this form here. All ones in a diagonal, zeros here. And then we will use substitution to finish it off. So let's check out a problem and go through all these steps. So let's try solving this set of equations. Now I did put together a set of steps you can do that will get you to your answer. So on the right here, I'm going to pull up these 7 steps, and if you follow this, you'll get to your answer. So let's check that out. The first step says rewrite the equations in the ordered form. So that means x, y, z, and then equals our number. Now if we look at this, it is all ordered, so all the x's are first, then all the y's, then all the z's, and then all the numbers. So step 1 is done. They are already ordered, and most of your homework problems will have them already ordered. So let's do step 2 then. So step 2 says rewrite the equations in matrix form. So let's do that. I'm going to pull up my matrix template here. So we're going to take our set of equations and rewrite this into a matrix. And that just means looking at the coefficients. So for our first equation, our coefficients, 1, 1, minus 1, minus 2. So 1, 1, minus 1, minus 2. We look at the second equation coefficients. We get 2, minus 1, 1 and 5. So 2, minus 1, 1 and 5. And then for the third equation, we've got minus 1, 2, 2, 1. We got minus 1, 2, 2, and 1. And there is step 2. Write the equations in the matrix form. So let's check out step 3. Now step 3 says get the bottom left position to be 0. Now the bottom left position, I mean specifically row 3, column 1. So I'm trying to circle that here with my cursor. That's this bottom left position here, this minus 1 right here. We want to get this minus 1 to be a 0. So right here, this minus 1, we want that to be a 0. And at this point, it is like a little type of puzzle game. You want to figure out which way can you add these equations together in order to get a 0 here. So notice that if we add row 3 with row 1, then we can get a 0 there. So let's make this our instruction step. We're going to replace row 3 with row 3 plus row 1. Let's do that. So we're going to add row 3 and row 1 together. So that means minus 1 plus 1, which is 0. Then we have 2 plus 1 to get us a 3. And then we have 2 minus 1 to get us a 1. And then we have 1 minus 2 to get us a minus 1. And that then is our instruction that we finished. And we accomplished our goal of getting a 0 in this bottom left position. So let's check out the next step. So our next step here, step 4, is get the middle left position to be a 0. And that specifically means row 2, column 1. So row 2, column 1 is this number here. So the next thing we want to do is to get this 2 to be a 0. So how can we do that? Well, again, it's like a little puzzle game. Got to figure out ways that you can do that. But if we multiply row 1 by 2, so if we multiply row 1 by 2, then we'll get a 2 right here. And then we can subtract off row 2. Let's make this our instruction set. Now, for the instruction sets, there could be many answers. There's many ways to do the instructions, so the way I'm doing it here isn't the only way you can do it. There are other ways. So we're going to do 2 times row 1. So that means this 1 becomes a 2, and then we're going to subtract. So 2 minus 2 is 0. Now going on to the next one, 2 times 1 is 2, and then we're going to subtract a negative 1. We're going to have 2 plus 1 to get us a 3. And we'll look at the next one. We're doing 2 times row 1, so 2 times minus 1 is a minus 2. And we're going to subtract another minus 1 here to get us a minus 3. Oops, I did not want to do that. A minus 3. And then finally, 2 times row 1, so that's 2 times minus 2, which is a minus 4. And subtracting then this 5 to get us a minus 9. And so we completed that instruction. And now look at our matrix. We have a 0 in this bottom left, and now we have a 0 here in this middle left. And that completes step 4. So let's take a look at step 5. Now it says get the middle bottom position to be 0. So the middle bottom position is right here, this 3. We now want to get this 3 to be a 0. That's our step 5. So let's look at what type of instruction would do that. So our goal is to get this 3 right here to be a 0. Now notice we can do row 3 minus row 2, and that would accomplish our goal. So if we do row 3 minus row 2, we use that as our instruction, and then we can get a 0 into that position. So row 3, 0 minus 0 means we put a 0 here. Now we have 3 minus 3, so we can put our 0 there. Now we have a 1 minus a negative 3, so that gives us a 4. And then we have minus 1 minus a negative 9 to give us then an 8. And so we completed that instruction step. Now notice, if you follow these steps along, how we're progressing. We now have zeros in this bottom left corner, which is what we want to get closer and closer to the solution. We want these 3 zeros here to be in this bottom corner. And now we want the diagonal numbers to all be 1. And so that's the next step I have written here. Step 6 says divide each row to get the diagonal number to be a 1. So step 6, we now want to get all the diagonal numbers to be a 1. So how can we do that? Well, first off, we already have a 1 here in a diagonal, so nothing to do with row 1. Row 2, if we divide by 3 on row 2, we can get that to be a 1. So if we divide row 2 by 3, then we can get this diagonal to be a 1. And then finally, to get this 4 to be a 1, we'll divide by a 4 on row 3. So here is our instruction. our instructions. We got 2 of them this time. And now let's do that. So row 2, we're going to divide everything by 3. So 3 divided by 3 is 1. Minus 3 divided by 3 is minus 1. And minus 9 divided by 3 is minus 3. And so we completed that instruction. And now for row 3, we're going to divide everything by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. And then we completed that instruction. And so here we go. Here's our matrix. We have all 1s on the diagonal. And we have all 0s in the bottom left corner. Which means we can stop with matrices and now put this back into equation form so that we can finish with substitution. Let me put this back into equation form. So if you look at this, remember the first position is x, second is y, third is z. So this tells us we have 1 times x plus 1 times y, and then minus 1z. And all of this equals minus 2. So if we look at the second row, it says 0 times x, 1 times y, and then minus 1 times z. And all of this is going to equal a minus 3. And then if we look at the third equation, the third row here, so we have 0 times x, 0 times y, 1 times z equals 2. So there we go. Just took the matrix and put it back into equation form. And why is that good? Well, because it tells us, well, we have z equals 2. And so now we can use substitution to figure out the rest of the results here. So let's take our z equals 2 and plug it in to the second equation. So our second equation here is y minus z, but we know z is 2, and this has to equal minus 3. So we can see then, adding 2 to both sides, that y must be y minus 1. So we have z equals 2, y equals minus 1. So now let's plug all that in to the first equation then, at the very top here. So we have x plus y. Now we know y is minus 1. And then it says minus z, and we know z is 2. And then all of this has to equal minus 2. So minus 1 and minus 2 is a minus 3. And then we'll add 3 to both sides to get our answer for x then. So our final answer, and the way we're going to want to write it here, is in an ordered pair notation. So we have x is 1. We know y is minus 1. And then we know z is 2. And there is our final answer. Writing it in ordered pair form. I am calling this ordered pairs. It's actually a triplet, though, now that we have 3 variables in there. And how do you know if this is right? Well, if this is right, you should be able to take this triplet, 1 minus 1 and 2, and plug it back into the original equation, and it should work. So the original equation way back up here. So if you plug those numbers in, it will solve all of those equations. So you can check to see if your answer is correct. So let's try another one. Here's a new set of equations. And let's do step 1. Now, step 1 says, rewrite the equations in ordered form. So if you notice for this one, I picked one where the equations are not in ordered form. So we want this to be x, y, z, and then equals our number. So for the first equation here, we do have x, y, and so we'll just move the z to the left here. Make that a minus z there. So this first equation is now ordered. X, y, z equals our number. Let's look at the second one. We have x. So this 3y here, let's get that to the left side. That'll be a minus 3y there. And then let's get this minus z to the left. And that'll make it a plus z. So that's ordered. Here's our x, y, z equals our number. And then the last equation is already ordered for us. X, y, z equals our number. So there is step 1. Now if we look at step 2, we want to now take our ordered equations and write them in matrix form. So that means we're just going to take all the coefficients and fill in our matrix. So our first equation here has coefficients of 2, 1, minus 1, and 1. We have 2, 1, minus 1, and 1. Our second equation has coefficients of 2, minus 3, 1, and 1. We're going to have 2, minus 3, 1, and 1. And then finally, the third equation has coefficients 1, 1, 1, and 4. We got 1, 1, 1, and 4. And that is step 2, getting our augmented matrix. Let's check out step 3. So step 3 says, get the bottom left position to be a 0. So that's right here, this bottom left position. We want this to be a 0. And you want to think of some instruction that will make that happen. Now again, there are multiple instructions you can do, so the one I'm picking isn't the only one. But something that we could do here is multiply everything in row 3 by 2. So multiply everything in row 3 by 2. And now we could subtract row 2 or row 1. It doesn't matter. I will pick row 1. Just because the numbers are slightly smaller. It doesn't have the 3 there. It's the only reason I'm doing that. But you could do row 2. And there's our instruction. And now we're going to carry out that instruction. So we're going to do 2 times row 3 and subtract row 1. So 2 times 1 is 2, minus 2 gets us our 0 there. And moving on to the next element here, 2 times 1 is 2, subtract 1 is 1. And then moving on to the next element here, 2 times 1 is 2, subtracting a minus 1, so we're going to add that then to get a 3. And then finally for our number here, 2 times 4 is 8, minus row 1, so 8 minus 1 will get us a 7. And that completes the instruction. And now we have a 0 in the bottom left corner there, which is what we want. Let's check out step 4. Step 4 says, let's get the middle left position to be a 0. So the middle left position is right here. We want this to be a 0. And how are we going to do that? Well, we could do row 2 minus row 1. So if we do row 2 minus row 1, we'll have a 2 minus 2 to get us a 0 there. So let's use that instruction set, and let's carry that out. So 2 minus 2 will get us a 0 here. Then we have a minus 3 minus 1 to get us a minus 4. Then we have a 1 minus a negative 1. So that'll add together to get a 2. And then 1 minus 1 here will get us a 0. And that completes that instruction. And now notice we have these zeros here, so we're progressing along. We almost have the bottom corner here filled with zeros. So let's check out step 5. Step 5 says we want the middle bottom position to be a 0 now. So that means this number right here. We want this to be a 0 now, and then that will complete having zeros all in the bottom left here. So what can we do to get this to be a 0? Now you have to be a little bit careful here. So for instance, this is not something you want to do, but I'm just going to write it out anyways. Let's say we do row 3 minus row 1. That's something we can do, because if we do row 3 minus row 1, we'll have a 1 minus 1, which will get us a 0 here, which is what we want. However, if we look at the first position, if we carry out this instruction of row 3 minus row 1, we'll have 0 minus 2, which means this 0 would get replaced with a minus 2. And we don't want to do that. We want to keep the zeros we already have. This work we've done, we want to keep. So this is not an instruction we'd want to do, because we'll lose our 0 here then, and we'd have to go back and fix that. So that's not something we want to do. We want to get rid of this 1 in a way that also preserves our zeros. So that means we're forced to use row 2. We have to use row 2 so that if we do 0 minus 0, we still have a 0 there. So in order to get this 1 then to be a 4, we would simply multiply 4 by row 3. So if we do 4 times row 3, we'll get a 4 here, and then we can add row 2 to that. So let's use this instruction. We'll carry that one out. So we have 4 times row 3, so 4 times 0 is 0, plus row 2, which is 0, so that preserves our 0 there, which is what we want. Then we have 4 times 1, which is a 4, plus a minus 4 to get us our 0 that we're shooting for. And then 4 times 3 is 12, plus row 2. So 12 plus 2 gets us a 14. And then 4 times 7, which is 28, plus row 2, which is 0, gets us a 28. And so there we completed our instruction set there. And notice now we have a zeros in this bottom left corner here, which is what we want. And now that we have the zeros in this bottom left corner, we want to get these diagonals now to be a 1. And that is step 6. So if we look over here, step 6, divide each row to get the diagonal number to be a 1. Let's take that, step 6 here. And so we want to get this 2 to be a 1. So we're going to divide everything in row 1 by 2. Now the second row, we want this minus 4 to be a 1. So we'll divide everything then by a 4th, or divide everything by a minus 4 there for row 2. And then lastly, in the third row, we want this 14 to be a 1. So we'll divide everything by 14 in row 3. So here's our instruction set. We have 3 instructions here. We can do that all at once. So let's do that. We're going to take the first row, divide everything by 2. So 2 divided by 2 is 1. 1 divided by 2 minus 1 divided by 2, and then 1 divided by 2. And so we completed that instruction. Let's go to the second row. Divide everything by a minus 4. So minus 4 divided by minus 4 is 1. 2 divided by minus 4 is minus 2/4, which simplifies to minus a half. And 0 divided by 4 is still 0. So we completed that instruction. And then for the last row, divide everything by 14. So 14 divided by 14 is 1, and 28 divided by 14 is 2. And then we finished that instruction set. So here is our place where we're at now, which is really good, because we have zeros all in the bottom left here, and we have ones on the diagonal. And so now we can go to step 7, where we write this all back then into equations. Let's take our matrix that we have right up here, and we're going to write this now back into the equations. So we see that there's this is a coefficient of 1 for x plus a half for y, and then a minus 1/2 for z. And all this has to equal a half. So that's taking the first row and writing it back as an equation. Now let's take a look at row 2. Row 2 says 0 for x coefficient, and then 1 for y, and then minus 1/2 for z. And all this equals 0. And then our last row tells us 0 times x, 0 times y, 1 times z equals 2. And so here are the equations then that result from this matrix. And now that we have step 7, we can see z equals 2. And so we can use z equals 2 and plug it into the second equation to get what y is going to be. So let's do that. So the second equation says y minus a half times z, which we just figured out z is 2, and all this has to equal 0. So 2 times a half is 1, and then adding 1 to both sides means y equals 1. So we have z equals 2 and y equals 1. And we can now use that information to substitute back into the first equation here, the x one. So we have x plus a half times y. We just figured out what y is. It's 1. And then minus a half times z. And we know what z is. Z is 2. And all of this has to equal a half. So here's what we need to clean up a little bit. So first off, 1/2 times 1 is 1/2. 1/2 times 2 is 1. And now looking at this, 1/2 minus 1 is a minus half. And now we can add a half to both sides to get then that x equals 1. So our final answer, using the parentheses, the triplet, so x is 1, y is 1, and we figured out z is 2. And that's our final answer. And again, you can take this and plug it into the original equation that we started with way up here, this one right here. So if you plug those answers into this, you'll find out it solves all these equations. And again, our final answer is where these three equations intersect. So let's check out another one. So here we go. So step 1, rewrite the equations in ordered form. So that means all the x's first, all the y's second, all the z's third, our equal sign, and then all the numbers. So as we can see here, this is already ordered for us. So step 1 is done. So let's check out step 2. Rewrite the equations in matrix form. So let's do that. So that means writing it all out, just the coefficients. So if we look at the first row here, our coefficients are 1, minus 2, minus 1, and 2. Looking at the second equation coefficients, we have 2, minus 1, 1, and 4. And then looking at the third equation coefficients, we have minus 1, 1, minus 2, and a minus 4. And there is step 2. Rewrite the equations in matrix form. Let's check out step 3. Step 3 says we want to get this bottom number then to be a 0. So we're going for this number right here, this minus 1. We want to get this to be a 0. And you want to create some instruction that does that. So something we could do is take row 3 and add it to row 1. And that would get us a 0 in that position. So here's the instruction. And let's do that instruction now. Let's add together row 3 and row 1. And putting all that into row 3. We have minus 1 plus 1 to get us a 0 there. We have 1 minus 2 to get us a minus 1. And then we have minus 2 and a minus 1 to get us a minus 3. Then finally a minus 4 plus 2 to get us a minus 2. And then that completes that instruction. And that accomplishes getting a 0 then in this very bottom left. So let's check out the next step. The next step says, step 4, let's get a 0 into this middle left position. So right here. Now we want to shoot for a 0 right here. And what instruction can we get to do that? Well, we could do row 2 minus 2 times row 1. So this instruction here, carry that out. We're going to take row 2 and subtract 2 times row 1. So that'll mean a 2 minus a 2 to get us our 0 there. And then moving along, we'll have a minus 1. Now doing minus 2, so minus 2 times a minus 2 is a positive 4. So minus 1 and a positive 4 would get us a 3. And moving along to the next element here, if I could highlight that, there we go. So we have 1 Now minus 2 times minus 1 is a positive 2. So 1 plus 2 would get us a 3. And finally we have 4, and we're minus 2 times 2. We have 4 minus a 4 to get us a 0. And then we did that instruction set. And now again, notice we have a 0 here and a 0 here. So that's good. All that's left is to get a 0 then in this position right here. And that's our next step. So step 5. Let's get a 0 into that position. So we want this minus 1 to be a 0. And again, at this point, we are forced to use row 2. We can't use row 1 because this 1 and this 0 will not preserve the 0. Once we have a 0 here, we want to make sure we keep that 0. So we can't use row 1 at all here. So we get a minus 1 here. Something we could do is we could do 3 times row 3. So that'll make this minus 1 a minus 3. And then we could add row 2 to that. Now again, this isn't the only instruction that will accomplish this. There are many instructions that could work. These just happen to be the ones I'm choosing here. So let's carry out this instruction. So 3 times 0 plus 0 is still 0, so that's what we need, preserve the 0. 3 times minus 1 plus 3 gives us our 0 there that we're shooting for. And then we have 3 times minus 3, that's a minus 9. Minus 9 plus 3 would give us a minus 6. And finally, we have 3 times minus 2, which is a minus 6, and then minus 6 plus 0. And we did that instruction then. So notice where we're at. We have zeros in the bottom left here, and this is what we want. Now we want to get ones on the diagonal. And that is step 6. Let's get ones on the diagonal. So to do that, we'll divide whatever we need to divide by. So we have a 1 already here, so we don't have to do anything with that. We already have a 1. Over here, though, we have a 3. So to get rid of that 3, we'll divide everything in row 2 by 3. And then for the third row, we want this minus 6 to be a 1. So we'll divide by a negative 6 on row 3. There's our instruction. And let's carry it out. So row 2, divide everything by 3. So 3 divided by 3 is 1. 3 divided by 3 is 1. And 0 divided by 3 is 0. We completed that instruction. And now for the third row, divide everything by minus 6. So minus 6 divided by minus 6 is 1. Minus 6 divided by minus 6 is 1. And we completed that instruction. So now let's go on to the final step here, step 7. And we want to rewrite our matrix back into equation form so that we can finish off with substitution. So let's do that. Looking at the matrix here, looking at this first row, it has 1 for an x coefficient, and then minus 2y, and then we have a minus 1z, and this all equals 2. Looking at the second row, we have 0 times x, 1 times y, plus 1 times z, and all of this equals 0. And then our last row says 0 times x 0 times y, 1 times z equals 1. So here are the 3 sets of equations we've reduced it down to. And now that we have a solution for z, we can simply plug that into the second equation to get what y is. So let's do that. Our second equation says y plus z, and we just figured out z is 1, has to equal 0. And so then there's our answer. Y must be then minus 1. So now that we have z equals 1 and y equals minus 1, we can now plug all this into the top equation to get x. So looking at the top equation, we have x minus 2 times y. We just figured out y is minus 1. And looking at the top equation again, we have minus z. We figured out z is 1. And all of this has to equal 2. So we'll clean this up a little bit. Minus 2 times a minus 1 is a positive 2. And then 2 minus 1 is 1. And then subtracting 1 from both sides tells us then that x must be 1. So our final answer, putting this into the triplet notation, which just means just like the ordered pair, except you get 3 elements in there. So we have x is 1, y is a minus 1, and we figured out z is 1. And there's our final answer. Now just a quick check, because I haven't done this yet, but I've said it works, but I haven't done it. Let's take the original equations and let's see if these answers work. So here's our final answer, 1 minus 1 and 1. Here's the original equations. So let's see if this works. Let's take the first equation and plug the information into it. So it says x, which is 1, minus 2 times y, which is a minus 1, minus z has to equal 2. So is that true? Well, we have 1 and minus 1, so those subtract out. And we have minus 2 times minus 1, which is a positive 2. So the first equation works. What about the second? The second says 2 times x, which is 1, minus y, which is minus 1, plus z, we figured out z is 1, and this has to equal 4. So does it? Well, 2 times 1 right here is 2. Minus times a minus is a positive 1. And so we have 2 plus 1, which is indeed 4. And finally, let's check the last equation. Last one says minus x, so x is 1, plus y, where y is minus 1. And then we have minus 2 times z, and z is 1. And all this has to equal minus 4. So does it? Well, 2 times 1 is still 2. So we have minus 1, and minus 2, which is indeed a minus 4. And so they do check. So the answer we got, so our final answer solves all of these equations, which it should, because our final answer is telling us where these intersect. So there you go. There is our lecture on solving systems of linear equations with some introductory matrix algebra here. And again, these 7 steps on the right, if you follow these steps, that should get you through every problem and to the correct answer. So I will talk to you next time.